Hey guys, Mr. Enyart here, Mr. Enyart's Mathematical Compositions. This is Grade 6, Module 6, Lesson 4. We're talking about histograms feeding off of our frequency chart and dot plot data that we've been working with the last few days. So this one's a little more long and tedious. Some drawing goes on with histograms because it's like a bar graph. But stick with it. It can be pretty fun if you enjoy being organized and making data look really nice and neat. So here we go. All right, so here we are with Grade 6, Module 6, Lesson 4, and we're going to be talking about histograms. And so we've been feeding off of dot plots and frequency charts. So this right here would be a frequency chart. But now that we're getting to intervals, when we use intervals, we can make a histogram, which is like a bar graph, or you don't have to use bars, but it's like a bar graph, but instead of having set numbers with bars, you have intervals with bars. So interval is a keyword to write down here and get to know. An interval is a range of numbers from one to the next. So extra small would be everything that fits 510 millimeters to 530 millimeters, and then a small would be from 530 to 550. So 545 would be a small. 515 would be an extra small, and so on and so forth. So make sure you understand the term interval, and a histogram, again, is simply going to be using intervals in a bar graph format. Now, for the sake of this video, I would recommend you go ahead and pausing and trying out this problem. All you would do here is just to reinforce that you understand frequency tables. Remember, the tally would be just every time you see anything that's between 510 and it says less than 530, you would put that in here. So this would be from 530 to less than 550. So 529 would go here, but 530 would go here. And then obviously 510, 511, 512, 513. And you tally those, and then your frequency would be the number form of that. So if we had a tally of, I don't know what the options would be, but let's say we had 5, our frequency would be written like that. So go ahead and see if you can do this, and then I'm going to go ahead and move on. So this is what the histogram would look like from the previous question. If we had a bar graph turned like this, and you can see that this bar right here, this first bar, recognize there are two bars showing, right? The first bar is from 510 to 530, so these would be our extra smalls. And then our 530 to 550 interval is our smalls, and you can see there's 8. And so now you can take that frequency chart, that tally chart, and you can put it into a very easy to look at and read graph. Now graphs obviously take data and make it much prettier to look at. Lets you see things, see trends, see highs, see lows, and a histogram is using intervals as your base, and then the frequency from the frequency chart goes on the y-axis over here. So notice that we have a title, we have a label for the frequency and the numbers on the left so that we know the frequency is how many of the head circumferences fit this interval. And the bottom is the head circumference in millimeters, and so there's a label down here as well, and then the bars go in between numbers. So we have our minimum to our maximum, but then our intervals are every 20 millimeters. We can see because that's what an extra small would be, then a small, and then this bar would be our mediums, then larges, then XLs, so on and so forth. So for my note takers, you can just basically write this stuff down and take a picture of this to remember or draw it what the histogram beginning looks like. So in these examples, you can see a couple different histograms, and feel free to pause the video, read them, and take a look. But the key thing to notice is that they look different in their shape. And when I say shape, I mean if you were to draw an outline around the bars, you would see that there is a clear difference in the symmetricalness, if that's a word, the symmetry of these shapes. And what we call ones that are pretty symmetrical, meaning they have like a line of symmetry and then it goes down to the left and down to the right pretty evenly, we call those normal distributions. And I guess I should spell normal right. And when we have them that are a peak at the beginning or at the end, and then it flats down, goes downhill the whole way, or it's going uphill the whole way, we call that skewed. And then we can even get more specific where is it skewed left or is it skewed right? So notice with the normal distribution or not skewed, the middle would most likely have a median, a mean, and a mode all the same. Okay, so data where you're right there in the middle, that peak, that's going to be your mean, your median, and your mode. Now, skewed data, and this happens to be skewed right, goes based on the tail. So you can think of this as the tail that sinks down to the right. Therefore, this is skewed right. Some call that positive skew because it's on the positive side of the bulk of the data. The mean will be on the right side here. So it's more positive than the median or the peak, the mode. And so when the tail's going to the right, we could call this one skewed right. And if it's skewed left, it would look the opposite. It would look like that. And then the mean would be to the left of the peak and would be towards that negative skew. So why don't you pause this section and try exercise 10, just exercise 10, A, B, and C, and then check back with me on how I went about it. So we have a histogram that shows the highway mileage of miles per gallon. And so here's our frequency, and our intervals seem to just be a gap of about 3, of 28 to 31, then 31 to 34. And so if we were to describe the shape as symmetric, skewed left, or skewed right, what did you think? Yeah, I see a big hump on the left and then a tail to the right. I'm going to go skewed right, because the tail is to the right and it seems to sink down that way. So then it wants us to draw a vertical line to show where the typical number of miles per gallon for a compact car would be. And so I would say it'd probably be somewhere along the lines of like maybe here. Right? We seem to have 3, then 4, then 5, then it drops all the way down to a 2, a 1, and it skips a couple, then goes. So right around there would be the typical amount. And then what does the shape of the histogram tell you about miles per gallon for compact cars? Not many can make it that far. This is definitely an extreme. Maybe it's a Prius or an electric car. But the majority of them are going to be between 28 and 40, or 28 and even you could stop it at 37. And that would be the main part of your data. So just for fun, do you think this one is skewed left, skewed right, or not skewed at all and normal? If you said normal, I agree with you. It looks to be pretty normal. It doesn't really have a tail on any one side. It kind of peaks, and I would assume that this would be our typical, our median, our mean, and our mode. So as always, go ahead and try the problem set, pause the video, go for it, and then check back with me on my answers. All right, let's get into it. I'll go up here to the first section. So we've got, for letter A, the interval of 24 to 30, less than 32, which would actually be 24 to 31, has the most actresses at 34. The shape is skewed right because the tail falls to the right. It tells you that the ages of the actresses are typically between 24 and 40 years old in order to win the Academy Award. And the interval that describes the center, I did that over here. I added up each bar, right? There's 2, 34, 27. This one was at 11, then 3, then 5. 1 and 1, and there was 84 total actresses, and then I divided that by 2 to find the actual median of number of actresses, and it was 42, which would fall right here on this line. So I just wanted to make sure that that was the center, and it was. An age of 72 would be included with the 72 to less than 80 interval, and so now let's move on to the frequency table below, and this was a fun one with basketball stadiums, so I'm going to zoom into my histogram, and as you can see, I gave it a title, seat capacity of NBA arenas. I wrote frequency on the left and the seats times 1,000, so I didn't have to write all those zeros. So this is 17,000, 17.5 thousand, 17,500. And so then I just put my numbers in. You know, this was 2, 1, 6, 5, 5, 5, 2, 2, 0, 0, and 1. And then using that histogram, I'm able to answer this question. The width of them is 500 because 17.5 minus 17 is 500. And you might say, but it's actually, isn't it less than? Isn't this how you say, don't you say it like this? 17,000 to less than 17,500. Yes, that is how we say it, because 17,500 would be included in the next interval. But remember, 1700 is a single one. It's not like we're just doing 17,499 minus 1,700, so the difference would be 499. We're including 1,700 in that mix, and so if you count it, 1,700 would be 1. And then 1701 would actually be 2. 1702 would be 3. And so you get that 1 extra from the 499 included when you write it like this. It is a difference of 500 for each interval. It goes 500, then 500, then 500, etc. Now C and D also go off of that histogram, so I brought it over here so we can see it. But the shape, I would say it's almost symmetrical, but slightly skewed right due to this little tail right here. So if you said skewed right, then you would say that we have a few on the far right that are outliers. But I would say it's almost symmetrical because you've got those two on the left with 17,000 to 18,000, and with, even though there's this gap here, right, you can almost count that as an outlier, and then you'd have it completely normal. So either way, skewed right or normal would work. And then the interval that describes the center, I actually would think 19 to 19.5 thousand would be the center. That's at the 14 and a half arena. And because there's 29 total arenas here. And so I went to the 14.5 right in the middle, and it fell in the 19 to 19,500 seats interval. And while it was seemingly long and tedious, we do have a tally chart to fill out here from this data, marking it off as we go, and then the frequency. And then we drew the histogram over here, so you can see it was given the title, Carbs and Fast Food Hamburgers. Carbs are in grams. Make sure the unit's down here, frequency on the left. Numbers are labeled, intervals are labeled, and I see a pretty normal distribution here, which means our center is pretty much going to be right here between 40 and 50 at about 45. So then what happens though if we switch the intervals to being 10s instead of 5s? That's all they did here. It's the same thing. They're just now going to say, okay, create a histogram where instead of having our intervals at a 5-gram gap, we're now at a 10-gram gap. Let's see what that does. So here's what I did. Again, carbs and fast food hamburgers, same labels and everything, but now you can see that I went from 20 to 30 instead of from 20 to 25, 25 to 30, so on and so forth. But you can still see a pretty normal, I mean, I guess you could try to say skewed right, but it's pretty solid that the peak's going to be right there between 40 and 50, which is the same as it was up top. So for these, the reason it has less bars is because it has less intervals. Less intervals means less bars, because we have a wider range between each interval. And no, neither of the center point nor the shape really changed when we changed the intervals.